Section, we're going to move on to working on more about the solutions to a compound inequality. And as we looked at in the previous worksheet, we saw how the differences between the connecting word being and versus or would change the compound inequality results overall. And in this part, we're going to focus on the idea of checking whether some number is going to be a solution for a given inequality overall. And in the first example, we're going to determine whether the given number is a solution to the compound inequality x greater than -3 and x is less than or equal to 2. And before we continue, if you need a reminder on how the solution works, we say a solution to a compound inequality is a number which, when we plug into all the inequalities in our compound inequality, results in a true statement. And for the inequality connected by and, we need both inequality to result in a true statement with a number plugged in, versus if we have inequality connected by or, we only need at least one of the inequalities to be true in order for the overall statement to be true. So in the first example, the numbers we're going to check are the number 2, 1, and 5. And we're going to look at them one at a time over here. So the first one we look at is when we have the number 2. Here, if we go ahead and plug the number 2 into the inequality, the first one we would notice, I'm going to number or letter this as letter A. And here we are looking at the number 2, and we want to see whether 2 is greater than -3 over here. And the first thing we see is 2 is indeed greater than -3, so this is true. And because this is in a compound inequality with a word and, we also need to check the second inequality. So the second inequality says whether 2 is going to be less or equal to 2 over here. And as we talked about before, when we have that equal included, we just need it to be less than or equal to 2. Same idea as before, because one of the scenario is true, it is equal, then we would say this is also a true statement. And in this case, when both inequalities are true statements, as a result of us plugging the number 2, we can say that yes, 2 is a solution to the compound inequality. And that's how we go through the checking process for inequality connected by and. And now we're going to continue to part B. So in part B, we would have the scenario for number 1, and we're checking whether 1 is greater than or -3 over here, and we know that 1 is indeed greater than -3, so this is a true statement. Now over here we would check whether 1 is less than or equal to 2 over here. We also know this is true, so that also tells us 1 is a solution to the compound inequality we have. Because both statements are true. Lastly, let's go ahead and check 5. So now for 5, if we plug that in, same idea as before, we check whether 5 is greater than -3. We can see this is a true statement. 5 is indeed greater. And then we want to check whether 5 is less than or equal to 2. And we can see 5 is greater than 2. So this is a false statement. And with that information, we have to say, because we require it to be and, then this overall is not true for both statements to be true over here. So we would say, no, 5 is not a solution to this compound inequality. And that's how we can write out the conclusion over here. And similarly, if we continue looking at number 2, the only difference between number 1 and number 2 is we change the word from and to or. I noticed there was a typo. I meant this to be or over here. And if we want to look at the case for or, remember the only condition we need to meet is at least one of the inequalities need to be true. And with everything we already checked before in the number 1, we can actually see that for part A, because both statements are true, then definitely at least one of the inequality will be true over here. So we would say that based on our part A from number 1, we know that yes, 2 is going to still be a solution to the inequality. I'm going to omit the rest of the sentence over here. Similarly, because for part B, at least one of the inequality gives us a true result, we plug 1 in, we would say 1 is still a solution to the compound inequality we have over here. Now for part C, notice before we said 5 was not a solution to the compound inequality when it was connected by and, which required both inequality to be true. Here we only require one of the statement to be true at least. So with that, we can say that in this case, yes, 5 is also a solution to this compound inequality when it's connected by or. And that's the difference it makes when we have different connecting words over here for a compound inequality. And that's how we would go about this type of problem. Make sure you understand the differences before you move on, and in the next part you'll get a chance to try your own hand on doing these problems to check whether any specific number is a solution for the compound inequality.